Hey there. This is your practice exam for your statistics class for chapter 4. This is without counting. I usually teach counting in my classes, but there are some teachers that don't include counting as part of that. So this will be the non-counting, and then I'll have a separate video with the counting problems. I want to show you where you can find your practice exam. And so I'm going to share my screen with you. So when you log into your Canvas shell, you're here, and where you want to go here is modules. And we'll give it a second. It kind of flashes for a second. There we go. And you'll go to where it says chapter 4. And in chapter 4, the very last item is your practice exam. And what'll come up is exactly this here. This here. And you can download it as a PDF, or you can just view it in the screen as you do that. But these are the problems that I'm going to be going through today. And our first problem is we have a bag that contains 6 marbles, red marbles, 3 blue marbles, and 5 green marbles. And if a marble is randomly selected from the bag, what is the probability that it is blue? So for number 1, let me switch screens for you. For number 1, I'm going to assume that you have your practice test up or printed out. And I'll flash to it a few times, but I'm going to hold off. Before I do anything, in this case, I need to add up the total number of marbles. So there's 6 plus 3 plus 5, 14. That's going to be my denominator. So the probability of it being blue, since there are 3 blue marbles out of a total of 14 marbles, that is my probability. Excuse me. Now I could get a decimal approximation and round it off somewhere. But this doesn't say one way or the other, so I'm just going to leave it as a fraction. In fact, some of the fractions today, I'm not going to even reduce. Number 2, we have a die with 12 sides rolled. What is the probability of rolling a number less than 11? So how many numbers are less than 11? Well, that's going to be 10, right? 1 through 10. So the probability of less than 11, notice we're not including 11. That's going to be 10 out of the 12. In this case, I will reduce this one. So if you look at the answer key and they have a decimal and I leave it as a fraction or whatever, then just check my fraction by dividing it out. Number 3, we have 2 6-sided dice. That means the denominator is going to be 36, 6 squared. What is the probability that the sum of the 2 numbers on a dice will be a 3? Now there's only 2 ways to get a 3. That's a 2 and a 1, or a 1 and a 2. If you can visualize the 2 different die being maybe different colors, so we can keep track of it. And there's a total of 36, so the probability of rolling a 3, there are only 2 possibilities, that's my numerator, out of the 36. And if I reduce that, that's 1 over 18. That means I have a 1 in 18 chance of rolling a 3. So quite low, actually. All right, number 4. They want us to come up with a sample space to flip a coin 3 times. So this one's going to take a little bit more space. Let's see how we're doing with the spacing there. All right, so we know flipping a coin, I'm going to use H for heads and T for tails. So my first flip could be heads or it could be tails. My second flip could be heads or could be tails. My third flip could be heads, could be tails. So there's my sample space. And I could write them out. H, it's the top one. H, tails, H, tails, H, tails, heads, heads, tails, heads, and now heads, tail, tail. Now we're to here. Tails, heads, heads, tails, heads, tails, so tails, heads, tails, 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 heads, and then tails, tails, tails. And you can see there's a total of 8 in this sample space. Moving on to number 5. Based on meteorological records, the probability that it will snow in a certain town on mine's getting cut off, on January 1st is 0.428. So for number 5, the probability of snow is 0.428. About a 43% chance on January 1st in this town that it'll snow. Now they want to find the probability that it doesn't snow. Well, that's the complement. And if you remember, the complement is going to be 1 minus the probability of snow, which in this case is 1 minus 0.428. 1 minus 0.428, 0.572. What's the probability that it won't snow on any given year in this town on January 1st? About a 57% chance that it won't snow. Next up is number 6. Let's see how we're doing here on spacing. Doing okay. Number 6. The probability that Luis will pass his statistics class is 49%, or 0.49. So probability of passing is 0.49. Find the probability that he will fail his statistics test. So the probability of not passing is going to be 1 minus the probability of passing, which is 1 minus 0.49, which is 0.51. 49% chance that he'll pass, that's a 9 there. 51% chance that he won't pass. All right. Number 7. A spinner has equal regions numbered 1 through 15. What is the probability that the spinner will stop on an even number or a multiple of 3? So we want the probability that it's going to be even or a multiple of 3. Now, this brings us to our rule. This is going to be the probability of rolling an even number plus the probability of rolling multiple of 3 minus the probability of even and multiple of 3. So 1 through 15, how many even numbers are there? There's 2, 4, 6, 8, 10, 12, 14. There's 7 of them. Out of 15. How many multiples of 3 are there? Let's do this. Let me write out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And I'm going to circle in red the even ones. And I'm going to count up the red. 1, 2, 3, 4, 5, 6, 7 of them. So I was right. Now I'm going to count up the multiples of 3. How many purples are there? 1, 2, 3, 4, 5 of them. However, you can see that we've double counted a couple of them. In fact, how many have both a red and a purple circle? There are 2 of them. So I've double counted 2 of them. So I got to subtract those out. So 7 plus 5 is 12. 12 minus 2 is 10. And it again does not tell us how it wants the answer written. So I will reduce that. So for this one, there's a 2 in 3 chance that it'll either be even or a multiple of 3. We have several of these that fall into this category where we have the 2 and then we subtract. Next up is number 8. And what I want to do is share my screen with you so you can see what I'm talking about here. So we have a total of 1,111 people, and we're talking about smokers. We have 4 categories: non-smoker, occasional, regular, and heavy. And we have men and women going the other way. So find the probability that the person is a man or a heavy smoker. So our overlap are heavy smoking men. That's going to be my subtract part, meaning I'm going to do heavy smokers, I'm going to do men, and then I got to subtract out the part that was counted twice. So let me flip back and show you what that looks like. All right, so number 8 wants to know the probability of randomly selecting a man or a heavy smoker. It's going to be the probability of randomly selecting a man plus the probability of randomly selecting a heavy smoker minus the probability that it's a man and a heavy smoker. Now, all my denominators are going to be the 1,111. Now, the probability of men, how many men are there total? There's 558 out of the 1,111. How many heavy smokers are there? There are 67. And how many heavy smoking men are there? There's 37. So this one was counted twice. Yeah, 558 plus 67 minus 37. So that's 588 over 1,111. And it again does not tell us how it wants to write the answer. So we could convert this into a decimal approximation. And I got that. We'll stop there. All right, next up, I need to readjust the screen here. There we are. And we are at number 9. Number 9. A sample of 100 wood and 100 graphite tennis rackets are taken from a warehouse. That's a total of 200 rackets, right? If 7 wood and 14 graphite are defective and 1 racket is randomly selected from the sample, find the probability that the racket is wood or defective. So we're looking for the probability that it's wood or defective. Well, again, my denominators are all going to be 200. Probability that it's wood, how many wood are there total? There's 100 of them. How many defective ones are there total? Now that's going to be the 7 plus the 14. That's the 21 defective. How many of them are wooden and defective? That's 7. And again, I don't know if they want us to actually get a decimal approximation. So there's our probability there. Number 10, we're back to that same table. Actually, it's a little bit different. The numbers are different in this case. I can show it to you real quick. So here we are at number 10. And same scenario, we have non-smoker, occasional, regular, and heavy smokers, and then we have the difference between men and women. And here they want to know, find the probability of getting a regular or a heavy smoker. Now, notice the regular and heavy smoker, these are what are called mutually exclusive, meaning these two categories have nothing to do with each other. So this makes it very easy. Let me switch screens back. All right, so the probability of getting a regular or a heavy smoker, again, these two are mutually exclusive, meaning there's no overlap at all. These are two completely separate, different categories. So this just becomes probability of regular plus the probability of being a heavy smoker. And the regulars was 142 out of the 1146. And of the heavy smokers, that's 84. A decimal approximation would be about there. So we're either here or we're there. Next up, how are we doing on spacing? Let's push that up. A bag contains 4 red marbles, 2 blue, and 1 green. They want us to find the probability of randomly selecting a not blue. There are 2 ways to do this one. We could just count the number of non-blue marbles, which in this case would be 9. And it looks like our denominator is going to be regardless. That's going to be 10, 11. Or I could do 1 minus the probability of blue. So we could do the complement. So we could do it either way. This one is small enough, it really doesn't matter. So I'll do the 8 plus 2. No, 8 plus 1, pardon me, because we want not blue, yeah. So we have 9 over 11. Again, the other way we could have done it was P of not blue is 1 minus P of blue. There are 2 blue. So both ways work. They get us the same answer, which is the point of mathematics. And it makes it beautiful. Push that up. Number 12. In one town, 44% of all voters are Democrats. If 2 voters are randomly selected for a survey, find the probability that they are both Democrats round to the nearest thousandth if necessary. So this one, they're telling us to round to the nearest thousandth. Well, since we want to know if their probability of both dims, well, the probability doesn't change for each random selection. So it's 0.44 times 0.44. And if you want to be cool, we just say 0.44 squared. Oh, and they told us to round it off to the nearest thousandth, which would mean on a test, if you put all 4 digits, I would not mark you off on that. Even if the computer marks you off, I'll go back and change the answer, the number of points. Number 13. All right. You are dealt 2 cards successively. That means without replacement from a shuffled deck of 52 playing cards. Find the probability that both cards are black. So in this case, and they want a simplified fraction. In this case, they are not replacing them. So once a card has been taken, it's no longer back in play. We're not putting it back in the deck. So 13, probability, both black. Well, for the first drawing, there are a total, half of them are black. So 26 out of the 52 are black. For the second dealing, there are now only 25 left out of the 51. And I'm going to go ahead and reduce that fraction to 1/2. And that is going to give me 25 over 102. That's it. All right. Number 14, a bin contains 64 light bulbs, of which 10 are defective. Now, if 10 are defective, that means that of the 64, 54 of them work. If 5 light bulbs are randomly selected from the bin with replacement, so we're going to take it out, we're going to inspect it, it works or it doesn't work, then we're going to put it back in. Are selected from the bin with replacement, find the probability that all the bulbs selected are good ones. Round to the nearest thousandth if necessary. Well, how many good ones are there? Of the 64, there are 54 of the 64. And I could rewrite it 54 over 64, 54 over 64 5 times, or I can just raise the whole thing to the 5th power. Let me show you how to do that. So I'm going to use parentheses, 54 divided by 64, close, and here's my exponent button. Ooh, you can barely see that. Let me scoot that up. Here's my exponent button, the caret, raised to the 5th power. And they said round to the nearest thousandth. And you can see I have a 7 there, but the 6 bumps that up to the 8. And the last one for this particular video is number 15. What is the probability that 4 randomly selected people all have different birthdays? Well, there's 365 days in a year. We're assuming it's not leap year. So the first person has 365 choices out of the 365. Now the second person can't have the same, so they only have 364 choices out of the 365. The next person, 363 out of the 365. Next person, 362 out of the 365. Last person, 1, 2, 3, 4. How many people? It was 4 people. 4 people. So that's it there. So I'm gonna go 365. Yeah, we're good. Times 364 times 363 times 362 divided by, that's a big number, that's times 10 to the 10th power, divided by 365, and I'm just going to raise that to the 4th power. 1, 2, 3, 4. Hey, look at that. In other words, there's a pretty darn good chance that you're going to all have different birthdays. If you randomly select 4 people, that they'll have 4 different birthdays. And 4 decimal places, it says 36. This is an approximation. And that is all there is to it. Thank you, everybody.